Hi everyone, today I will introduce the engineering research method. My topic is shared design of concrete based on different standards. The integrity of most reinforced concrete structure was damaged during the earthquake and require rehabilitation and renewal, which means that the engineering designer considers all aspects of design to avoid shear damage of the structure. It is also required for professional engineers to take them into account and to design methods to improve the shear strength of concrete according to different standards in order to ensure the structure integrity and increase the life of the construction. In et al. Found that the strengthening effect will be better as the number of DRC layers increased. For another research compared with JSE proposed method, the experimental result of Canada method for beam with shear span to depth ratio of 2.5 are also in excellent agreement, while the corresponding prediction are more consistent with the experimental data. In summary, incorporating FRP is an effective to enhance the performance of the material, but the low interlayer shear strength and susceptibility to deterioration lead to damage of the members. Also, to avoid cracking, splitting, and shear damage of concrete elements, designers prefer to improve the performance of concrete in all aspects through reinforcement to obtain safety design values by comparing the codes of different countries in order to better protect the life of the building. For the application of shear reinforcement part, the experimental results show that the use of neutral network model to evaluate the application of the construction concrete beams result in a safer analysis with a 32% improvement of the reliability index. And another studies indicate that the lateritic concrete beams exhibit an approximately linear relationship between shear strength and reinforcement ratio, such that the ultimate shear strength value with increase in reinforcement. In summary, the laterite concrete beams exhibit higher ductility and good crack control in all performance aspects compared to plain concrete, which means that the performance and serviceability of concrete after cracking is improved. The problem reached in this paper is the use of different types of fibrous material to stiffen concrete elements for enhance their performance. The high tensile stress and corrosion resistance of fiber material can be combined with concrete structure for reinforcement to restore or improve structure performance. Furthermore, this reinforcement method without increasing the same weight of the structure is conducive to construction and reduce the occurrence of construction accidents. The group was first dry in an oven at the temperature of 100 degrees Celsius for at least 48 hours. The ductility, compressive, and the shear strength were observed and analyzed according to the Australian standards. The concrete elements combined with jute fiber and balsa fiber groups reinforcement sheet were analyzed for shear strength as well as compressive strength after heating. Secondly, the heated balsa and jute groups were tested on concrete members with effective anchorage less of 0.8 and 1 respectively. And the property of balsa fiber concrete members in terms of shear and the compression strength were observed. It is also essential to control the numbers of layers of reinforcing fibers. In conclusion, compared to the jute fiber reinforcement sheet, balsa has higher heat resistance. Balsa reinforcement sheet increase the third layer where damage occurs, while the numbers of layers of reinforcement sheet contributes the improvement of concrete performance. And lastly, the advantage of this research is that the on-site collection of experimental material to ensure that the data reflects true values. Then the sufficient data are available to support the reliability of concrete reinforcement method. However, the limitation of this research is the control of temperature. The heat resistance of basalt is so excellent that the upper limit of temperature it can accommodate was not reached in a experiment. That is the reference. And thank you for watching and listening.